Perform the following matrix computations. Now, matrices are super useful. For one, the computer allows us to, program these in and do all sorts of operations on them. But it's really important that you understand what's going on first before you just plug things in blindly and hope that the answer is right. So let's talk about what multiplication of matrices looks like. So suppose I had ABCD times E, F, G, H, like that. So when you're multiplying, you multiply row by column. Okay, row by column. So I would have a result would be a matrix that had, and when I multiply, I'm multiplying A times E plus B times G. So this would be AE plus BG. Now that I've done that row and column, I now do the first row times the second column. And that goes in the second slot. So I have AF plus BH. I recognize this might seem confusing at first, so just follow along, and eventually you're going to get the pattern. Okay, so now we've multiplied. Let's get these highlights out of here. So we've multiplied to find the top. Now we need to do the same with the bottom. So we will multiply the second row by the first column, and that will appear here. And so that becomes C times E plus D times G. And then I will multiply the second row by the second column, and that will appear here. And that is CF plus DH. Now you might be wondering, how do I decide where which thing appears? Well, if you look at my green, right, if I were to move this over, where do the highlights overlap? Well, the green highlights overlap in that bottom right. Similarly, when I was multiplying the yellow, if I were to move this on top of that, it would overlap in this element right there. So we refer to these as row columns. So this would be 1, 1. This would be 1, 2. This would be 2, 1, and 2, 2. Row by column. Row by column. So anyway, let's multiply these. So my result would be here, and so I have to multiply the first row by the first column, and that ends up in this spot right here. So it's 4 times 0 plus 2 times 3. 4 times 0 plus 2 times 3. I now multiply my first row by my second column to go right here. And so that is 4 times negative 1 plus 2 times 9. Continuing, I multiply my second by my first, 2, 1, and that goes right there in 2, 1. And so that is 8 times 0 plus 0 times 3. And lastly, I multiply my second by my second to give me my position in 2, 2. And that is 8 times negative 1 plus 0 times 9. So my result then is 6 here. I have negative 4 plus 18 is 14. I have 0 here, and I have negative 8 here, and this is the result of the multiplication. So take these slow and see if you can follow the process. Perform the following computations, solve for x and y. So the first thing we're going to do is multiply these and then see if we can figure something out to do with it. So we have, again, 1 row and 2 columns. And so we have a 1 row by 3 columns and a 3 by 2. And as long as these middle numbers are the same, we can multiply these. So they are So let's multiply. So we have 3 times 5 plus 2 times x plus 1 times negative 6. So that would be 15 plus 2x minus 6. That's our first set of multiplication. Our second set, 3 times 4 plus 2 times negative 2 plus 1 times y. So that would be 12 minus 4 plus y. So simplifying that, we get 9 plus 2x, and we get 8 plus y. And we know that's equal to 10, 6. Which means the first element must be the same as the first element, and the second element must be the same as the second element. So, I'm saying 9 plus 2x must be the same as 10, and 8 plus y must be the same as 6. So solving that, let's take them one at a time. I'll move this over. So I'll subtract 9 from both sides, and I get 2x equals 1. Divide by 2, I get x equals 1/2. So 1/2. Similarly, here I subtract 8, and I get y equals negative 2. So the x and y that solve it are x equals 1/2, y equals negative 2, which you could write as 1/2 negative 2 if you'd like. So again, the idea of multiplying matrices, you have to figure out where you put the answer, and kind of following this example again, maybe watching me do it again is useful, and just getting used to this pattern. These will come up a lot later, as well as in Algebra 2 honors a lot.